We've covered quite a bit of theory already, so I'm sure that by now you're itching to see how to actually configure our Cisco devices, our routers, and our switches. Now, Cisco do have graphical user interfaces, like web-based interfaces that you can use to configure the devices, but in the real world, everybody uses the command line. Well, experienced engineers use the command line because it's much quicker than using the GUIs. And the operating system that is used on enterprise grade Cisco devices is iOS. So in this section, you'll learn how to connect to the router or the switch, and then how to make your way around the command line. Just before we get into that, we're going to have one more theory lecture where I'll talk about the different operating systems that are available from Cisco, because there's not just iOS. So we'll do that first, and then we'll get into actually how to connect to the device and how to make your way around the CLI. Let's do that now. In this lecture, you'll learn about the different operating systems that run on Cisco's different router and switch platforms. Now, you don't actually need to know this for the exam. The exam focuses purely on iOS, on Cisco routers and switches. So if you're wondering why am I including this then, the reason is that it's something that you would wonder about anyway, and I want to explain to you that by taking this course and learning how to configure Cisco iOS, it's going to enable you to work on any of the different Cisco routers and switches, because from a management and an administrative point of view, it's pretty much identical no matter which actual operating system you're working on. So I'll start off by giving you a bit of history. Many people think of Cisco as being a routing and switching company, but they actually were just a purely routing company when they started off. And when they did start off, iOS was the original operating system that they used on routers, the same operating system that's used today, although obviously it's gone through quite a few upgrades in the time since Cisco started back in 1984. So they were originally a routing company. To offer switches, that was through an acquisition. They bought Crescendo in 1993. And the Catalyst switch product line came about because of that acquisition. The original operating system on the Catalyst switches was CatOS, but that's been deprecated quite a long time ago now. Cisco firewalls evolved from another acquisition. That was the acquisition of Network Translation back in 1995, and Cisco got their PIX firewall from that, which uses the Finesse operating system. Now, both the Catalyst switches and originally the PIX firewalls, it's now the ASA firewall, were ported over to the iOS operating system over the following years. So Cisco standardized on iOS for all of their network infrastructure devices. There are some other operating systems on some of the newer router and switch platforms, Phil. So iOS runs on the majority of Cisco routers and switches, but some of the newer platforms do have these new operating systems. Let's look at those now. So on the Cisco Nexus and the MDS data center switches, they run on NX OS. On the high-end service provider routers, the NCS and the CRS, and also on the ASR9K and the XR12K routers, they run on iOS XR. And on the ASR1K service provider routers, they run on iOS XE. So you're maybe thinking, oh, well, this is going to make things more difficult if there's all these different operating systems, but really it doesn't, because all of the different Cisco operating systems, they are incredibly similar from the command line point of view. If you know a command in iOS, it's probably going to be exactly the same command on all of the different operating systems as well. As far as administering and managing them, they're all nearly exactly the same. So you're maybe wondering, well, if managing them is exactly the same, why is there the different operating systems? The main reason and where they're different is under the hood. iOS has got a monolithic kernel, meaning that if one process running on the router crashes, it can crash the entire router. The other newer operating systems have got microkernels, and the processes run in separate protected memory address space. So if one of the processes crashes, it shouldn't affect the running on the rest of the system. So these other operating systems are mainly on the higher end routers and switches, but on the enterprise grade routers and switches, they're still running iOS. Now, don't think that iOS is a bad or an unreliable operating system. It's been purpose-built by Cisco, who are the biggest networking company in the world, to run on enterprise-grade routers and switches. So it is very hardened. It's still very, very reliable. In this lecture, you're going to learn how to make the initial connection to your Cisco device so you can get it configured and up and running. Now, to get to the command line interface for your normal day-to-day management of a Cisco device, after you've set it up, you will use Secure Shell, that's SSH, using an SSH client like PuTTY to connect to the device's management IP address. In enterprise networks, a secure login will typically be required, meaning you're going to need to enter a username and password. We want secure login for our network devices on production networks because we don't want just anybody to be able to log in there and mess with our configuration, obviously. As well as having that secure login, a username and password, that will usually be enforced through integration with a centralized AAA server. AAA stands for Authentication, Authorization, and Accounting. The reason why we use that external centralized server is we don't want to have to keep a user database on every single one of our routers and switches. We want to just have one database in a central location, and whenever we log into any router or switch, it's going to connect to that server to check that the username and password is valid. Now, don't worry about SSH and AAA for now because they're going to be covered in a later lecture, but I do want to give you a demonstration right now of how you would normally log into a Cisco device on a production network. So let's fire up PuTTY for that. So I've got PuTTY open here, and you can see I've got some saved sessions where I saved the details of how to connect to that device. So I'll load the session for this particular production router here. You'll see it puts in the IP address, and I want to use SSH because it's a secure protocol, and I'll click on Open to Connect. It will connect to the router and it asks me to enter my username, so I'll do that, and it also asks me for my password, and I've now logged into the command line of the router, and I'll be able to enter my configuration commands from here. Okay, let's go back to the slides again. Cisco devices do not usually have a default IP address, so we need to set one up before we can connect to the device in the way that I just showed you. This is a bit different than a lot of other vendors' devices. For example, if you buy a router from D-Link, it will have a default IP address on there that you can connect to straight out of the box. But Cisco devices don't have that. They don't have a pre-configured IP address. We need a way to connect to the device to do the initial configuration of it, including adding the IP address. And that's where the console connection comes in. So let's take a look at that. So we're looking at the back of a Cisco router here. This is a 2621, quite an old router, but the modern routers look very similar. to this as well. You can see some of our different ports on the back of the router. We've got serial 00 and serial 01. They could be used for wide area network connections. Below there, we've got Ethernet 0 and Ethernet 1. They can be used for our production Ethernet traffic. We could also use those ports for connecting in for management as well. Actually, the serial ports or the Ethernet ports, any kind of port that you can put an IP address on, if you allow it, you could connect to that port for management purposes. But out of the box, none of those ports have an IP address on them. We need to connect to the router or the switch to do that initial connection. That's what the console port is used for. The console port is different than an Ethernet port. It does not have an IP address on there. So the console port, it's a special dedicated port which is just used for management purposes. And to connect to that port, again, because it's not an Ethernet port, we don't use a normal Ethernet network cable, we use a console cable. The console cable will be shipped with the router or switch in the box. And this is what a console cable looks like. So on one end, you've got a serial DB9 connector, which connects to your laptop. And on the other end, you've got an RJ45 port, which connects to the router or the switch. Both routers and switches have got that exact same console port. Now, this gives us a problem because way back in the day when Cisco routers and switches first came out, most PCs would have a DB9 serial port on there. It was commonly used for connecting to an old 56K modem. But if you look at any modern PCs or laptops, they don't come with a DB9 connector anymore. So how are we going to use this cable? Well, the way that we use it is with a USB to serial adapter, which you can see in the second picture here. So that's the same console port again. We separately purchase a serial DB9 to USB adapter. We can now plug the serial port on the console cable into the DB9 side, and the USB side can get plugged into our laptop. Typically, this won't work straight out of the box. You'll need to install a driver onto your PC as well. So that's the original console cable. Cisco are aware of the DB9 problem, so on their newer platforms, the newer routers and switches, they come with a new type of connection and a new type of cable. So now they come with this different cable, which is USB to mini USB. On the router or the switch, it doesn't have that RJ45 port. It's got a mini USB port on the Cisco device, and the normal USB connection plugs into your laptop. So you don't need to buy that extra serial to USB adapter. You're still going to need to install a driver for this on your laptop though. Okay, so that's what the cable and the connections look like. Next, let's actually fire this up in the lab. Okay, so I've got my router powered on and I've connected a console cable between my laptop here and the console port on the router. Then I open up PuTTY, and rather than using an SSH session, because I'm connecting to the console port, I'll choose the option to use serial. Then in the serial line, make sure you're using the correct COM port for your particular laptop, and then you can click on open to open up the console session. And then I can see that I'm in the console session. I can click in here and hit enter, and there I get my command prompt where I can now configure the router. As well as for the initial configuration, the console port can be very useful for troubleshooting. For example, if a device's IP addresses become unresponsive, you're not going to be able to SSH to it, but you could go down to the server room and you could plug your laptop directly into the router or switch with a console cable and see what's going on. It can also be used to troubleshoot the boot up process. You can view the device booting up from a console connection, but this is not possible with SSH because the system must have booted already before the IP address will be live. So if the system hasn't booted up, the IP address isn't there, you can't SSH to it. but you will still be able to use the console connection. The console connection can also be used for out-of-band management. This is where you use a different path, meaning not the normal production network, to connect to the device for management. Let's have a look at that. So this was our local area network again. And if we're connected into the production network, then over our RP connection, we can SSH to that side of the router. Another thing that is commonly done on enterprise networks is they will put in a separate out-of-band management network, meaning this connection is not going over the production network. The benefit you get from that is that if you have a problem with the production network, which is maybe caused by your routers and switches, you can still get to them over that alternate path. So as an administrator, we're going to be connected to the management network, and we could SSH to that side of the router. That's fine, that will work, but again, if IP is not up and running on the router, we're not going to be able to do that. So what you'll see some companies do is put in a terminal server. Now this is not a Windows terminal server, it's a Cisco terminal server, which is a completely different type of device. With the Cisco's terminal server, this actually runs on a Cisco router, and it will have an Ethernet connection on one side, which is connected to the management network, and a console connection on the other side, which is connected to your production router or switch. Now what you can do is you can SSH over the management network to the terminal server, and from the terminal server, you can then console into your normal production router. Okay. So that's how we make the initial connection to the command line on a Cisco device. In the next lecture, we'll take a look at how to navigate our way around there. In this lecture, you're going to learn about how to navigate the Cisco IOS command line. Now, the way it's going to be done is through a live demo in the lab. And because I've got a heap of tips and tricks to show you for how to make your way around the command line, to save you taking your own notes as we go through here, I'm also going to attach a PDF, which is a summary of everything that we're going to cover here. The scenario you see here is I've got a brand new router, I've taken it out of the box, and I've hooked up a console cable, and then I've powered the router on, and it's currently going through the boot up process. And because it is a brand new router, it's going to ask me, would you like to enter the initial configuration dialog? If I entered yes here, it would take me to a command line driven wizard, which would help me do the initial setup. It's not commonly used. Normally we'll enter no here, so that's what I'll do here. Ask me, would I like to terminate auto install? Yes, I would like to terminate that. I'll see my interfaces on the router coming up, and then I land at the user exec prompt. Now, we're not commonly going to be working at the user exec prompt because there's a very limited set of commands that we can enter here. If I want to see what those commands are, I'll enter a question mark. So I just hit question mark on the keyboard there, and it shows me all of the commands that are available at user exec mode. Notice down at the bottom I see more here. This indicates that there's additional commands, additional output that I could see. I can hit the enter key and that will scroll through it line by line, but this would be a fairly tedious way to scroll through a lot of output. So what I'll do instead is I'll hit the space bar, and that's going to scroll through it page by page. So I can just hit the space bar multiple times until I get to the end of the output there. Notice in PuTTY over on the right here, I can scroll back through the previous output. Now, by default in PuTTY, it doesn't include a lot of lines of scroll back. So what I can do to improve that is go up in the top left here, right click, and change settings, And if I then go to the window tab, I can set my lines of scroll back here to 2000. I've done that already. By default, you're going to see a much smaller value here. And that can be annoying because sometimes you do need to scroll back through quite a few lines of output. So I'd recommend that you set this to a high value. Okay, so you saw that I can hit the question mark to see all of the available commands that are available at this level in the command hierarchy. And as I said earlier, there's not really a lot that I can do at the user prompt, so I'm going to go to privileged exec mode. To get there, the command I need to enter is enable. So I hit enable, and notice that the command prompt changes. When I was in user exec mode, the prompt showed the name of my router, which is just router, the default right now, and then a greater than symbol. But when I go to the privileged exec mode with the enable command, it changes to show the host name and then a hash. So you can tell by the command prompt what level you're currently at. If I wanted to drop back down to the user level, which normally you wouldn't want to do, I can enter the disable command. Okay, so now I'm going to go back up to the privileged exec mode, which is also known as the enable prompt, and I'll show you that we can use command abbreviation here. So rather than typing in the full command enable, I can just say en and hit enter, and that will bring me back up. And I could also use an abbreviated command to go back down to the user prompt again. So I'll try entering di and hit enter, but what I see now is that this is an ambiguous command. The reason for this is whenever you use command abbreviation, there has to be just one possible unique match. So if I now enter di and a question mark, it will show me all of the possible commands that begin with di. And you can see that there's 3 possible commands here: dir, disable, and disconnect. So when I typed in di, it didn't know which one I meant. So if I wanted to actually put in the abbreviation for disable, I'd have to enter DISA, and it would now know, okay, there's only one possible command, I must mean disable. I don't need to go back down a level though, so I'll just stay at the enable prompt for now. Next up, I'm going to check what all commands begin with SH. So I'll enter SH and a question mark, and I can see there's only one possible command, which is show. On Cisco routers and switches, you will use the show command a lot because we use it to get information about the device. So the shortest way we can type that is just SH. If you want to see what the available show commands are, I'm going to put the same command in, but I'm going to have a space now. So it's SH space and then question mark. When you include a space, it shows you all of the possible keywords for that particular command. So this is the context sensitive help now. So again, I can see all my different show commands there. I'll hit the space bar to scroll through all the different options. If I wanted to break out of a command output without scrolling all the way to the end, I can hit the control button and C at the same time. That will break out of the command. And if I scroll back, you'll notice the first available option there was show AAA. So let's use that for our example and show you how you can figure out commands with the context sensitive help. So if I type in show AAA space question mark, it shows me all of the available options that would be available after show AAA. So if you need to enter a particular command, but you can't remember exactly what command you needed to enter, this can be really helpful in that situation. Similarly to the command abbreviation, we can also do tab completion as well. For example, you see my first option here is show AAA accounting stop cache. That's quite long to type in. So what I'm going to do instead is I'm going to say show AAA ACC, which makes it a unique match. And now I can hit the tab key and that will auto-complete the entire word for me. While I'm at the command line, I can use the backspace to delete what I'd entered already. So that's what I'm doing here. And let's deliberately put in a typo here. So notice I've put show AAA accounting stop quiche. That should be cache. So I've put in a typo. If I hit enter, you'll see I get the error message, invalid input detected. When you get this error, it's usually because you put a typo in. and I can see the marker here shows me exactly where that typo was. Let's have a look at another error. So if I do show AAA and hit enter, you see the error I now get is incomplete command. I have to carry on with the command by putting in one of these additional options here. If I do a show run question mark as an example, carriage return, that means that I could hit enter. These are all optional keywords. I don't have to enter one. I could actually hit an enter here to get some output. So at the enable prompt, that's where we'll most commonly be using show commands. The other main command we'll use here are debugs. So I could enter debug space question mark, and I'll see all of the possible debugs here. The difference between a show command and a debug, when you enter a show command, it gives you point in time information about the state right now. When you do a debug, what will happen is that the output will be updated in real time. So for example, if you were debugging OSPF and an OSPF packet came in, you would see it show up as and when the packet came in. Okay, next thing I want to show you is how to actually make configuration changes on the router or switch. At the enable prompt, that's mostly for information there. To actually make changes, we go to global configuration. To get there, it's configure terminal. Now the abbreviation for this is you can just type in conft. You'll use this command a lot, so you'll be using conft a lot as well. Okay, while we are in global configuration, let's hit the question mark, see all the available commands here. So we could do that the same as we did at the enable prompt. If I hit Control C to break out of this, another thing to notice is that the prompt changed again. So when we were at the enable prompt, the prompt showed our hostname and then a hash. When we're at global configuration, it's router and then config in brackets. So the hostname, config in brackets, and then a hash. Okay, we're up to the 10-minute mark in this lecture. I know when I'm learning, I don't like to sit too long. I like to take frequent breaks. So what I'm going to do for this lecture is I'm going to split it into two parts, which are going to be about 10 minutes each. So go get yourself a coffee and I'll see you back here for part 2. I want to show you how the command history works in a second. So I'm just going to enter a couple of random commands in here. This is just adding a couple of host entries. Don't worry too much about what this command does. It's not important. I'm just using this to illustrate the command history coming up in a second. So I'm adding IP host server 1 and IP host server 2. Next, I'm going to change the name of my router. I'm going to give it a host name, but I'm going to deliberately make a mistake here. So I type in router 1 and hit enter, and you'll see it tells me invalid input detected at the marker. It's because I forgot to say host name at the start here. So let's correct that, but rather than typing the whole thing in again, when you make a typo on a command, the quickest way to correct it is to hit the up arrow, and then that will bring the previous command back again. Now what I could do is I can use the left arrow to move the cursor to the left. But if it's a big long command, a way that you can do this quicker is by hitting Control A, and that will bring you to the start of the line. So I hit the up arrow to get the previous command back, then Control A to move to the start of the line, and I can now type in hostname and a space, and that's the correct command now. So I hit enter, and notice that the prompt changes to reflect the hostname that I just entered there. Next, I'm going to show you command history. So I'm going to hit the up arrow a few times, and you'll see each time I hit the up arrow, it cycles back through my previous commands. That's why I entered those commands earlier. Notice that it only cycles back through commands at the same level. I'm in global configuration here, so it's cycling back through the commands I entered in global configuration mode. It doesn't show the commands that I entered at the enable prompt or in the user mode. Now I'm just going to delete this command to show you the next thing. While I'm in global configuration, if I try to do a show command, so let's do a show IP interface brief. and I hit enter and I get the invalid input detected. You know, I said earlier that where you'll most often see this is if you've put in a typo. The other place where you'll often see it is if you're at the wrong command level. When you're a beginner, this is the most frustrating thing about the iOS command line. You'll make this mistake a lot where you're going to be at the wrong level when you enter a command. Our show and our debug commands are entered in privileged exec mode at the enable prompt. If I try to put it in global config, it's going to give me an error message. But this could be really annoying, so thankfully there's a workaround for this when you want to enter a show command, because it is very common to put show commands in. And what I can do is I'm going to enter the same command, but I'm going to put do at the front. So again, I'm going to use the command history here. Rather than typing the whole thing in, I hit the up arrow to get the command back, then Control A to go back to the start of the line, then I type in do and a space and hit enter, and you'll see that the show command is going to work now. And when you enter do, that will work from any level unless you're actually in privileged exec mode. At privileged exec mode, you have to do the show command without do. At all the other levels, you put do in front of the show and then it's going to work. So far we've seen the user exec mode, the privileged exec mode, also known as the enable prompt, and global configuration. There's other levels when you're configuring something specific on the router. Meaning at global configuration, this is where I would do my global configuration for things that affect the router as a whole. If I wanted to configure a specific interface, I need to go to that level in the command hierarchy. So looking at my output here, I can see the interfaces I've got available on this router. If I wanted to configure interface fast Ethernet 00, for example, putting an IP address on there, I have to go to interface configuration mode. So to get there, the command is interface, and I'll use tab completion here. So interface fast Ethernet 0/0. And notice here that in the output above, fast Ethernet, that was capitalized at the start. Here, I don't need to use capital letters. iOS is not case sensitive. It doesn't matter if you use uppercase or lowercase, with one exception that we'll talk about a little bit later in this lecture. So I go to interface fast Ethernet 00, hit enter. You'll see that the command prompt changes again to show config-f, and I can see very clearly that I'm at the interface configuration level. If I want to drop back down a level, I enter the exit command, and that takes me back to global config. If I wanted to go to the enable prompt again, I would enter exit again, and that will drop me back to the enable prompt to privileged exec mode. Notice from here, I can enter interface fast Ethernet 0/0. This is going to give me an error message because you have to go up through the levels one by one. You can't skip straight from the enable prompt to the interface prompt. So I'll go back through the levels. So I enter config T to get to global configuration, and then interface fast 0/0 to get to the interface mode. So when you go up through the levels, you have to go one by one. When you drop back down the levels, you can actually do that all in one go. So it was exit to drop down one level. To drop all the way back to the enable prompt with one command, I can enter end. Another way I could have done that would be by hitting Control C on the keyboard. Okay, a couple of the most common commands you'll use when you're working on a Cisco router or switch is the show IP interface brief that you saw earlier. That will show all the interfaces on the router and the state of the interface, whether it's up or not, and also the IP address configured on the interface as well, if there's an IP address on there. The other show command that is used really often is show running config. That shows the entire configuration on the router. And I'll hit the spacebar here to scroll through the configuration. And you can see even on a new router, it's a really long configuration file and it's going to take quite a while to scroll through there. On a production router, it's going to be even longer because there's going to be actual configuration in there. there are switches we can use for the show run command which are going to help us target the actual part of the configuration that we want to look at. For example, if I want to look at the configuration for a particular interface, I can do show run interface and then the interface I'm interested in, and it shows me just that part of the configuration. So to see the interface config, it's show run and then interface and the interface number. The other switches that we can use on the show run command use a pipe. And to give you an example of that, I can do a show run and then the pipe symbol, which looks like that. And then the available options after there, the ones that are most commonly used, begin is probably the most commonly used. I can also include and exclude as well. So for example, I could do show run begin hostname, and this will show me the running config, but starting from where hostname shows up in the running configuration. Now, you know I said that there's an exception to when the iOS command line is case sensitive or not. Well, when you use a pipe, this is actually using a regular expression which is case sensitive. So if I did a show run pipe begin and try not to put a typo in and then hostname with a capital H and hit enter, you'll see it's going to just go straight back to the command line again. This is not an error. The reason is that hostname with a capital H is not in the running config at all, so there's no output to show. To give you examples for the other pipe options, I could do a show run and then pipe it to include interface, and it will show me all the lines that include interface, meaning the word interface in the actual output. I can also do a show run and pipe that and exclude interface. This will show me all lines from the configuration that do not include the word interface. And I can also do a show run and pipe and section interface. That will show me the configuration for all my different interfaces. Now, when you've got a production router, you're not going to just have interfaces configured on there. You'll have other things like routing protocols, for example. So I could also do a show run, pipe it section, and put in the particular part of the configuration I want to see here. Now, if you put in a question mark, it's not very useful here because it just tells you line telling you to use a regular expression. But for example, I could put in section BGP to see information about the BGP routing protocol. I haven't configured it on this router yet, so I'm not going to get any output, but if I was using BGP on this router and I had a big long configuration on there, this would be a useful command because it would just take me straight to the BGP config and I could see that very clearly. Okay, so that's how to navigate the iOS command line. In the next lecture, we'll take a look at how to manage our configuration files. In this lecture, you're going to learn about iOS configuration management and the running configuration and the startup configuration. So I'm going to make some configuration commands to demonstrate this for you. I'm going to go to global configuration, so I enter config t. Notice right now that I've just got the default set up in this example where the hostname is router. If I enter the command hostname router1 and hit enter, you'll see that the hostname changes immediately. So in iOS, whenever you make a change, the change takes effect immediately. When you make the change, it goes into the running configuration, which is the configuration that is in effect right now. But as well as having the running configuration, we've also got the startup configuration. So running config is the config in effect right now. The startup configuration is the configuration that will go into effect when the router is next started or rebooted. And commands that you entered in the running config do not get saved permanently until you explicitly copy them from the running configuration to the startup configuration. So you can see here, I entered the command hostname router1. That went into the running configuration immediately, and my hostname was immediately changed to router1. But if I now do a show startup config, and notice my not so deliberate mistake. I'm at global configuration, so I can't enter a show command. I told you you'd make that mistake a lot, right? I still make that mistake too. So I'll hit Control A and make that a do show start. And let's do tab completion to check what the command should be. So the full command is show startup config. I'll hit enter, and notice here that the host name is still router. It hasn't changed to router1. So in the startup config, it's still hostname router. If I now do a do show running config, I can see in the running config that the host name is router1. So if I now reloaded the router, it would come back and the change would not have taken effect. Now, this is actually deliberate because it allows you to back out of mistakes. Say if I made some changes on the router and I made some catastrophic changes, but I hadn't saved it yet, the easiest thing to do is to just pull the power out of the router and then plug it back in again, boot it up, and it will come back with the configuration that was already on there before I'd made those changes. Now, obviously, that's a fairly drastic thing to do. It requires a reboot of the router, so you would only do that as really a last resort. Okay, so I've changed the name of my router to router1 in my running config. I haven't copied it to the startup config yet though, so it's not going to be persistent across a reboot. To do that, the command is copy run start. And again, I'm at the wrong command level, so I'll end to drop back down to the enable prompt. To do your copy run start command, you have to be at the privileged exec mode. So I can now do a copy run start. It'll ask me the destination file name I want to save it to. Pretty much always we're going to accept the default here and just hit enter. It will take a few seconds to build the configuration, and I get the OK message telling me that yes, it's been copied to the startup config. So if I now do my show startup config command again, you'll see that the host name is now router1 in there as well. So it's permanent. If I reboot the router now, it's going to come up with that as the configuration. The next thing I want to show you is how to back up your configuration. Now, Cisco do have tools like Cisco Prime Infrastructure that can be used to automate this from a centralized server. That's not tested on the exam, by the way, but you can also back up manually as well. The way to do that is I'm going to copy the running configuration. I'll hit the question mark now to see where I can copy it to, and you'll see one of the options here is flash, which is flash memory on the router. So I can do a copy running config to flash, and I have to give it a file name when I do this. So I enter a colon and I'll call it my-config. Try to do it without a typo. There we go. It'll say what do I want the destination file name to be. Yes, I want it to be called my-config. And I've now backed up my configuration to flash. To verify that, I can try a show flash, and there you see I've got my config is in there. If I wanted to restore from this backup, the way I do it is by copying it to the startup config and then rebooting. But when you do a copy, it's going to actually merge the commands rather than replace. And typically I would want to replace the entire startup configuration. So the way I do that is, first off, I erase the startup configuration. So I enter the command erase start. It's telling me an incomplete command, so let's use the context sensitive help. To help here, I'll hit the up arrow, space question mark, and it tells me unrecognized command. Okay, this is because I'm working on an older router here. So on an older router, the command is write erase. And that will tell me it's going to erase the NVRAM file system, which is where the startup config is saved. Do I want to confirm? I hit enter to confirm that, and that will erase my startup config. I can now copy flash my-config to the startup configuration, confirm that, and I would now reboot the router to come back up with that configuration. Now, hopefully you're thinking it's not a very good idea to back up the configuration to flash on this router, because if the entire router blows up, I lose the router and I lose my backup as well. It's always a bad idea to back up a device to the same device. You want to back it up somewhere else. So the easiest way to do that would be to copy the running config to a TFTP server. So I enter copy run TFTP and hit enter. It will then ask me for the IP address of my TFTP server. Let's say this is at 10.10.10.10. I hit enter, then the name of the file name I want to use. Let's say I'm going to use router1-config, and then I could enter today's date in here. Say that that's a date and hit enter. And it will then connect to the TFTP server and back up the configuration there as a text file. I'm getting an error message because I don't actually have a TFTP server in the lab here. While I'm saying that it will show up as a text file, another thing you might wonder is, okay, how do I check what the actual contents of my backup are? If it's saved to flash, the way you can do that is using the more command. So I would enter the command more and then a space and then flash my-config, and that will print out here what the contents of that configuration file are. The last thing that I need to tell you here is where the different configuration files are stored. Now, for the device to boot up, it needs to initially load the iOS operating system image, and that is stored in Flash. Once the operating system is up and running, then it will load your actual administrator configuration from the startup config, and the startup config is stored in NVRAM. That's non-volatile memory, so it's persistent across a reboot. The running configuration is stored in normal memory in RAM, and it's loaded into RAM memory from the startup config when the device boots up. Okay, that's it. See you in the next lecture.